open a new file and then open a current file or existing file and save data, that's what. And then when you see this edit, again you see this edit, rotate, appearance and all those things, and then it comes up. And then view, and then part only model, there are some nomenclature we need to understand to go exactly into this. And then layout also is an advanced level. So then I will go later on in detail. And then setting up, we using this unit setup and then also working grid setup. There are two things you can do it, and then units and also working grid setup. Units already I have set it up in the beginning of this program. When I open the new database, then you don't have to do it again. But what I do, working grid, he has mentioned in a second problem, I will go through that, and then first problem doesn't require anything. And then solids, you can see this already, the solids available, a box, and then which is prism, and then the square prism, and then cylinder, and then spherical ball-like, and then conical. So they're all information we have. So then we can use this, any of these solids straight away, create one of this model. And we are not creating any flexible body. See, please remember guys, in any of the CAD package, if you want to create a flexible body, it is a real challenge for every one of us. And this is one of the powerful software we can create a flexible object, which is very, very handy. Okay, that is what I am trying to tell you. But when you go to the mechanics of solids 2, they might be using working model at the moment, but they might change it to this Adams later on. That's what I'm trying to negotiate with them. And then if they change it, probably we are much better off. So we can coordinate with these IT guys and then set this one up properly. So now coming back to this file. So I open up this already new database, and then that takes up this graphics user interface and then also working area here. The model one by default name, it has displayed here. What is that? See, from the tutorials, what you have got, the document, you should clearly read this one, please. What is the problem description here? I find the displacement velocity and acceleration of stone after 1 second when the stone with zero initial velocity falls under the influence of gravity. That is what the first task is about. If you drop a stone and then you are trying to calculate after 1 second what is the distance it has traveled and what is the velocity. And then acceleration, of course, we know it is g equals 9.81 meters per second square. What we are trying to do here, we calculate manually first using all our analytical method. Please do that. Okay. Then you compare the result. See, this is what at the end of this solution, what you can see, the end of the tutorial, sorry. You can see he has calculated this using all this formulas. This is pretty simple and then straightforward. What you need to do, first solve this problem and then try to correlate what is your exact values in the simulation and then comment on that. And then in order to put the reports in, I will show you how to put it in. Then I will start off with this tutorial. So we have already done this one, the step 1, this create a new model and then falling stone. And I did not do this one specifically. We might end up a little difficulty, but I'm trying to resolve this one with a supplier and then I will get to know in a couple of days. For the gravity, you have this already global Y it has set up. The unit you have set up this MMKS and then said OK. And that is how you are in this environment. Now what I do, I take this sphere, a ball which is just, and then click this radius, and then if you check this radius, it's going to just stay whatever the value you key in. And he says that it is around 5 centimeter from the tutorial. I'm just fixing at this coordinate system. This is inertial reference. Right? I've just created one model. So then pick this rigid body sphere and then just place it here and then exactly at 0, 0, 0, x0, y0, c0. And then Now that is what your second step. Main toolbox, this is what your main toolbox is about, this solid box. And then sphere, take up the rigid body sphere and then put the radius as 5 centimeter and then place it. And then rename. So you talk about this rename and then first stone, then choose part, the rename falling stone. I go this and click this, right button click and part. Here I can say this rename and I can change here falling stone.
Not falling stone or falling
No,
stone?
just falling stone.
Does in the notes it says dot falling dot stone?
Yeah,
Yeah.
that's right.
That is the reason I am trying to bring up this falling stone. If it is not working here,
Action is the object name. Right.
okay, so then right button click here, okay, immediately right button click here, validate, field validate successfully, okay, then say okay. Now, like all other CAD packages, you can also see the history has developed here. The tree, history tree, you can just see this is body has created. I need to get the connection, motion, forces, but this body is only a single body. There is no connection between anything. We just drop this one in the under gravity, right? There is no connection between any body. So once this is done, so now the next step, what is talked about? So this is what, verify your field, say okay, okay, then you change the name. Then set mass to 1 kg. This is where, guys, I was about to give you your student last digit, but now I don't want to confuse anymore. But just do your this 1 kg itself. Okay, no problem. Just pick this 1 kg. Most of you guys getting up the same number, but please work it out yourself. So then define choose input. How do I do that? I go to this, select this solid, a sphere, and then right button click under part falling stone, and then just put a click this modify. And then you can see the body falling stone, it has changed. Category mass property defined by geometry or not that. I use this user input and then I just put this 1.0. See guys, also remember here, I did not put kg here. The reason why it's already in this mm MKS units. The unit before we have started off. So say okay. Now this part is done. So 1.0, the mass is click OK. Just now I need to calculate. What do I calculate? The displacement and then velocity acceleration, right? So I come back to this graphic user interface, right button click, part stone, not modify. Now I go with this measure. Earlier we have used this rename. Second instance we modified this, and then third instance we are measuring. So measuring in what direction? This is in y direction, right? So I name this as displacement, and then CM position, coordinate measuring position. So leave orientation and all other by default and say okay. Then and also please what you do is you click this create a strip chart that creates a small chart here. So then it says that the following message reported, that goes to the third party and all, just okay, no problem. Just go to third party, it doesn't matter for me. That's what I would say. That is done. See, what is this? This chart will show you, so what is your displacement once you run an analysis. So second instance, I want this part, go measure with this y direction, and then I say velocity. Okay, so y direction velocity, and then create a strip chart. We're going to create one more chart. You can see this velocity, displacement, but still nothing has populated. And then third one is acceleration. Right button click, part, measure. And that is also in y direction. Set, okay. So we have all the three data here. So that's the strip chart side. So what I am trying to say that you make a clear distinction between strip chart and then full chart. So later on I'm going to show that. So now this is ready to go for a simulation. That's what it runs. Set up and run simulation. So what you should do, select the translate and then drag this working coordinate, all those things just forget about. So you have a simulation tool here. So then pop-up window, just bring it in and then you run an interactive simulation. So when you run an interactive simulation, see it says this 5 to 50 and change to, because it will give you a little bit slower end time. So then I can see what is happening. Now I can also see this verifying model. One of the messages pops up, model verified successful. So then you are good to go. So what we do, we try to look at this object where it is going to follow. So then what I do, I use this Z button and then zoom in, and then T button translate, and then R button rotate. Just right away it was just Z and then zoom in and out. You are scroll in and out and then transform and then move. This hand move, you can move using your T and then also using your rotate. I will show you this rotate in the other model. So rotate, you can rotate. So that you can also see, you can rotate like this. And then apart from that, you can also see the front, and then you can also the top view and rigid right view and all you can create. But I am interested in only the particular view at the moment. Now it is ready to go for a simulation. Just check this one. See, it fell down.
What is that going? -4903.
Where is that 4903? Here.
Displacement.
What is this 4903? Can you tell me?
It's dropping down, so it's going down 49 millimeters. 4,903 millimeters down. It's going down that much.
Yeah. And then what exactly? Look at this. Then why this is not created? See, oh. One moment, please. See, this is displacement chart. This
All
is
the
what?
same.
No, not all the same. So what we should be doing, look at this, what I did. Button click, part,
Really? Sounds like an awful lot.
measure.
Yeah.
When you click this one,
It
you
wasn't a
remember,
It was one
you set
kilo.
this velocity,
Yeah, 49 minutes. Look at that.
That's a lot.
velocity 1, y direction.
You don't need underscore for that?
I need to change this, look at this, to velocity.
Okay.
Otherwise it won't come up.
Good one. Z, why are you doing Z?
Change characteristic.
Which one? What is it?
Why are you doing Z? Why are you changing it from Y to Z?
The exit axis.
Y. Measure velocity. The y direction?
Put a 1 after the velocity or something.
No, because it is already existing, this velocity one name.
Actually, but that's cool. Push further left.
Velocity underscore one I gave you, so the y direction,
So you just be like
this is not position, this should be velocity. Okay, apply. And then you can see now, this velocity has changed, right? It's a different graph. So, yep, and then measure acceleration.
Let's be able to give it
And then I need to change this to cm acceleration, which I didn't do it. That's the reason you didn't get it. So can you see these three different charts? Now, how do you calculate manually? So then, if you use any of you are look at this, these values, where this is coming from. See, and the theoretical value, what you can see is 4905 millimeter, but the simulation value, what you got is 4903, and there is a 0.04% error, and that is what is acceptable. That is what people will go for. So, in the sense, within 5% error, definitely the simulation can go ahead. If you get these two big difference, let us say 10, 15%, 20% and all, you got to rerun this simulation. That is what it means. And this error is very, very marginal. We are coming very close to this answer. Okay? That is how the simulation has become predominant in an engineering industry. You go with this 1% error, let us say, they are really an excellent engineers. And that is what they talk about in an engineering industry. So it is not only here, and then when you do this FEA also this, if your stress value, strain value, all if you are coming to within 5% error, and then that is what people will do. And then when you do the physical testing, that it avoids a lot of physical testing, and this is totally a virtual testing what we are talking about. This is much easier to do it sitting in one place rather than building so many models and testing again and again. And that is the reason you will have to learn one of the software. And then apart from that, what I told you, this mechanics of solids, mechanics of machines too, they are going to use it. But they may be using lower version of this MSc Adams, but as the time comes in, definitely they are going to adopt this one. But that is much easier to work with. But not the complicated model. But simple models, definitely you can work out with this working model, but not the complicated models. So now, coming back to this chart. So you are okay with this simulation? It's pretty straightforward. Look at this. Now displacement. Right button click. If you click this right button, plot full chart. Can you see this full chart? Transform to the full chart. Okay. Guys, this is what I want you guys to have it. So just take this one of this screenshot here. Okay, I create this Word document now. So you can name this, what is that, MSc Adams simulation assignment. Okay. Then your analytical method. First thing, what you do, analytical method calculation. And use all the formulas and then calculate.
That's it, yeah.
Hmm?
All you have to do is just show the picture and then show your calculations. That's all you have to do.
Yeah, correct. So analytical method, use all the formula, calculate. Okay. Then compare your results. Okay. Compare simulation result and comments. When you are comparing the simulation result, how do you do that? I have got this already, my picture here. I just paste it on my document. Okay, this is displacement.
So for the first one, do we have to do our velocity and acceleration as well?
Mm. You have to do it for all three. So all three for the calculation and also all three simulation. Full chart, not the strip chart.
Yeah.
Remember. Okay. So then any mechanisms, guys, you can create these mechanisms in CAD model, and then you can import those CAD models into this MSA Adams, and then you can simulate for dynamics, and then kinematic analysis and kinetics. Yes.
Do you want us to put the percentage error?
Yes. If you see this, if you see any percentage of error, just make sure that.
Can you give us a formula for percentage error?
Start on Google, comes up.
Okay.
How do you work it up?
So I got actual value and then your displayed value divided by multiplied by 100. Right?
Actual
So-
minus theoretical.
Yeah. No, theoretical value. What do you get this? Actual value to the theoretical value ratio.
Theoretical minus actual.
No, first actual value divided by actual value what you can see on the simulation. Simulated value.
So
Simulated value.
Yeah, then to the theoretical value.
Minus.
Simulated minus theoretical.
anyway.
Bio.
The second one is velocity. So then you already have calculated, just go back to this MSA Adams. So then you click this one and go back to our simulation, just press F8. Then right button click on this velocity. Right click here and then get this full chart. And then actually this MSA Adams itself is going to generate some report for you guys, but that is not working at the moment. So I don't want to again hold up for something. So velocity. So just you. So just copy this one and then also your acceleration. Go back to this and then acceleration chart, this full transfer. This one pretty easy guys, second one will have you will have a bit of challenge, so we'll try to work on that. Okay, I need to copy. And acceleration.
Yeah.
So now percentage of error.
Hey Chris, should you be able to do me a favor?
So calculate
Just focus
percentage
quickly.
error.
Just write some stuff down. You can get in on that as well if you want.
I'll put it to the group chat.
And then comment. Yeah, then you are good to go submit. But what,
What comments do you want?
so what do you observe from this simulation? If you see something different, so I don't know whether everyone will get the same number. They might mess up something, and then you will definitely have a totally different value. Because this problem is straightforward, but next problem is not going to be. So you may having totally different numbers, and then make sure. If you observe anything different, then but don't get stuck. So then submit as it is with the comments. Okay, just, you need to get practice this one, so then when you are using it for next year, next semester, our project work. Okay, but when you come to the project work, don't be surprised, okay, I will not learn and we didn't get it, but we take it to the advanced level in the project. So, be familiar with this process.
Number 2.
So, what you do, this is your exercise 1, right? The falling stone is exercise 1. You write down this is exercise 1 here. And then also you continue in the same document. Please don't submit 2 or 3 documents. Continue the same document with this, got them some pages, access. So now you have any question how to submit the report? You're okay? Is everything clear?
Like drawing on a blackboard,
Yes,
all I